Then we go into the application. Pose the question. We're now going to take this into applying it. And, pose the question, do you want $1,000 every day for the next 20 days? Or do you want $1 doubled for the next 20 days?
I think this is the most important too, because finally, when we're talking about an equation, we can say to them, I mean, we did it when we wrote equations, we're taking a field trip, it costs $20 plus $3 per person, but they don't care. I mean, they don't care when you tell them this. But I mean, this is actually, so exponential functions is something, exponential growth models are something that you would think you don't use. You don't use exponents really in the real world, but here's how it can be used. Look at this problem, poll them, make them decide which one they'd rather have, and then.
So we definitely want to make sure this question gets into the lesson.
Yeah, I think so.
So we need to be time-honored throughout.
Even if it's just introduced and they do it for homework.
Yep.
But as long as it's introduced, this is how you do it, start it, do you understand, now you can go home and do it.
Yeah.
Come back tomorrow and we'll talk about it, that's fine.
Yeah.
But yeah, introduce it because you definitely want them to see it. And do it on their own, not all together. We could easily say, look, the exponential grows this much and the linear grows this much, but we want them to come up with it on their own.
Right. Because I think that's going to be the wow factor.
Well, I mean, that's the place where I think I mentioned in the break that so far they haven't seen the difference in terms of the
real life,
the quote drastic difference, and until they get to something where they can see beyond the first 4 or 5 items or beyond the scale on the calculator graph. And so if you want that in the lesson, it needs something like that problem needs to be part of the lesson.
And then the next lesson that we're teaching is when we actually give them the growth model. So maybe this would be a good tie between the two like this is your attention grabber too for the next lesson that we teach on the growth model.
So what is in that lesson, just roughly?
They learn the actual equation that they plug into. Well, I mean, it's a lot of plug and chug, but the y equals c parentheses 1 plus r to the t power. They learn the actual
Or they do money.
Growth model.
Rate, percent increase.
And they do percent, right.
So
I mean, that would be a lot of real life application too, that whole chapter. But
so what we're trying to do is tie the connection between what they've learned to going into this complicated equation that they're going to get the next day. So that question is sort of the, all right, let's make the next step, and it's sort of the introduction the next day to pull it together. So the actual lesson may not actually have them drastically seeing the difference.
right, depending on if we actually get to plug in those numbers and get that done. If we're just giving them that problem, making them pick one and taking it home for homework, they're not actually seeing the drastic increase. If we are actually doing it in class, if we have time to do it in class, which we may.
I think we should make an absolute point of doing it, and then in the end, some of the kids have filled out the table, they've formed their opinions, some of them see how drastic that difference is. We can graph that.
That's the wow factor.
Yeah, that's really when they're going to say, there is a huge difference.
Yeah.
So to not fit that in, I think it would be a loss.